We are going over finding features of a quadratic from a table. The features will include a y-intercept, x-intercepts, line of symmetry, the vertex, domain, and range. And then from there, we will write the equations in standard form, factored form, and vertex form. Okay, so to start, let's find our y-intercept. Okay. And then in this table, actually, okay, to start, we're going to find our y-intercept. A y-intercept is what we get when we do nothing. So let's make some notes really quick over here. So we do nothing when we input 0 for a table. Okay, and what does that look like? So I want to remind us that this is what we do and this is what we get. Okay, so these are the values that we input. The outputs are the values we get. And I'm noticing here that there's a pattern 1, 2, 3, 4, 5, 6, but I'm missing the 0. So I need to find out what do I get when I do nothing. Okay, to do that, we're going to look at the rates of change here. So this one looks like it goes down 3. This one looks like it's going down 5. And this one looks like it's going down 7. Notice that the change in x, the input of what we do, is always just 1. So this is relevant on the right. But I notice this is changing. Okay. Hopefully everyone notices that these numbers are just changing by 2. So it's getting smaller by 2 each time. So that means that if I follow that pattern, I should go lower by 9 because 9 is 2 less than negative 7. Negative 9 is 2 less than 7. And that would lead us to have a y-intercept of 0, 24. Okay, that means I do 0 and I get 24. Okay, where's that at? A negative. I need to make sure I put that in there. Okay, so from here, we're going to start looking at our x-intercepts. And x-intercept is what we do to get nothing. So we're flipping the idea here. Instead of doing nothing, we're getting nothing. That means we want an output of 0. These two are instances of outputs of 0. So they are our x-intercepts. This is nice. I don't have to do any extra work for that. I just have to write them down, or we just have to write them down. Okay. So 6 gets us 0. And when I input a 4, when I do 4, I get 0. Okay, so those are our two x-intercepts right there. Okay, so next thing, a line of symmetry is always in the middle of my repeated values. Okay, and I have 2 repeated 0s here. So we can tell that that occurs here in the middle of my repeated values. Okay, so we're looking at the x value for that. So that's going to be an x value of 5. And so now I've drawn a line that cuts my repeated values. That implies is that I should have another value somewhere over here that would also be green. Okay, so down 24, about 5 away, so I guess it would be at 10. So at this spot, I'd have another green dot because of that line of symmetry. Okay, and next, once we know our line of symmetry, we also know what the vertex is. Okay, so that's this point right here. This is our vertex. And we know that because it's in the middle of the repeated values. Okay, it's where we change direction. What do I mean by that? Is right here, if we're counting this as -1, this one over here is actually a +1. Notice that we actually are changing direction from an increasing to a decreasing. So that's how we know that it has to be our vertex. Okay, so our vertex, let's write that down here, is when I do 5, I get 1. Okay, so this is looking like a maximum here. It looks like 1 is bigger than all my other values. Okay, it's bigger than -15, it's bigger than 0, it's bigger than -3. So 1 looks like it's going to be my maximum. that lets me know that my graph should look like a downward parabola. Okay. So domain for most functions that we deal with is all real numbers. Okay, meaning that we can do anything and we'll get some result. We'll get something from it. Okay, range, though, is limited by that one, the maximum that we can possibly get. So y is less than or equal to 1. Notice how it shades everything down there in the bottom. We can get values that are down there, but nothing bigger than 1. Okay, so when we make our graph, we want to make sure our graph is in this range and domain. Cool. Okay, so now we're going to look at finding the equations. I'm always going to recommend that you start with your x-intercepts if you have them, and we do. So we need to write an equation that when I plug in a 0, when I input 0, when I do 0, I get nothing. And when I do 4, I get nothing. So an equation that when I do 6, I get 0. It'd be, let's say that the x is 6. 6 minus 6 gives me 0. Okay, and notice that it inputs a line here that goes through exactly where I want it to. And then when I input a 4, I want to be able to get 0. So 4 minus 4 gives me 0. And so that gets the other one. And then I can multiply these two ideas together. So x minus 4 makes a parabola that intersects or has x-intercepts at both 4 and 0. But I'm noticing that it's popping out of the green. So we wanted it to be facing down. So that lets me know that our a term should be -1. Okay, once we have our factored form, we can now multiply it together using an area model to find our standard form. So when we multiply it, I like to use the area model. It's not the fastest, but it is one that makes a lot of sense to a lot of people. So x times x is x squared. X times -6 is -6x. X times -4 is -4x. And negative times negative makes a positive. And then 4 times 6 is 24. So we write out what we get. And we have 1x squared. We have 4 negative x's and then 6 negative x's. When I put those together, that ends up being 10 negative x's and then 24 units. Okay. So when we write our equation for that, we get x squared minus 10x plus 24. Okay, notice that there's a big difference here, right? This one goes up, but we want it to go down. So once again, we need to fix the a term. So don't forget that right in the front, we had our negative value. That means that I need to distribute that negative to all the terms inside of my standard form. We end up with -x squared plus 10x minus 24, which that lines up with our y-intercept. So minus, plus, and then minus. Cool. So now it lines up where we want it to. Okay. Lastly, we have our vertex form. And the vertex form is also pretty straightforward. Just like the x-intercepts, we find our x value and we make that give us a 0. Okay, so I'm going to make a parentheses. Whenever we write parentheses in an equation, we're always trying to make it so the x value gets us 0. So if x is 5, I'm going to take away 5 to make that equal to 0. Notice that lines up our axis of symmetry. I want to make it a parabola, so I'm going to square it. We need to make it face down, so I make it negative. And then I'm going to shift it all up 1 to line up with my original. Okay, so let's do some checking here. And a rule on checking, or something to remember on checking, And if you don't remember this, you at least remember that you should check 3 points. Okay, but if you don't want to have to check all 3 points, just make sure you do not check the ones you've already used to make that equation. So for instance, this vertex form here, I used the vertex to write it, so I'm not going to use it again. Okay, so instead of using the vertex, I will check this equation by using the y-intercept or an x-intercept. Okay, and be fairly sure that it's going to work if it lines up that way. Cool, so let's do that. So I know that when I plug in a 0, I'm supposed to get a negative 24. So when I plug in 0, I get 0 minus 25 squared plus 1. And then that turns out to be negative 25 plus 1, which indeed is negative 24. Okay. And then I can check my other equations. My factored form, I'm actually going to use the vertex to check my factored form. Okay, my factored form is negative x minus 6 times x minus 4. So let's plug those in. So negative 5 minus 6, and then 5 minus 4. Something I'm going to say is that it's nice to input your inputs in parentheses. So that way we keep track of which one the input is. Okay. When we do that, we end up with negative 1 times positive 1, and that is a bunch of 1s, but we have 2 negatives there, so that means we're going to end up with a positive 1, which is what we expected to get right here. Okay, so once again, I'm going to check my standard form right here, also with 5, 1 with my vertex. It means when I input a 5, I'm supposed to get a 1, so let's try that. So negative 5 squared plus 10 times 5 minus 24. 5 times 5 is 25. 10 times 5 is 50. And then minus 24. 25, and that makes 25 minus 24. And 25 minus 24 is indeed just 1. So it lines up. So I just verified my 3 equations by using points that I had not used before to create those equations, okay? So I use my vertex for my standard form and my factored form, and then I use my y-intercept to check my vertex form. Cool, thank you.